Hey, hi, folks. Welcome to my channel. My name is Aakash, folks. Welcome to my channel. Okay, so we will be continuing this particular thing, sort of stuffs. We'll try to learn it. Uh, Try to understand more about what is a KNN classifier is all about. Okay, so KNN classifier is KNN nearest neighbor. That is like okay, K nearest neighbor. So it can be used for both classification and regression basically. Okay, so it is the simplest machine learning algorithm and it's also known as a machine lazy learning. Why? Why? Maybe they will be asked why it is lazy learning because it does not create a generalized model during the time of training. It does not create a generalized model. So the testing phase is very important. So it does actual testing is very costly in terms of time and money, and also called as an instance based on memory based learning. So in KNN classification, the output in a is a class membership object is classified by the priority of votes of its neighbor. When with an object being assigned to be class most common among its k nearest neighbors, k is a positive integer, typically small. If k equal to 1, then the object is assigned to the class of that single nearest neighbor. Alright, so next we will be understanding in KNN regression the output of this property value. The value is for average for the value of a k nearest neighbors. Okay, so you will be finding the distance functions. Okay, Euclidean distance like xi minus x bar, x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is a particular thing you will be going to do, this particular equation you will be going to do, and all the distances are only the it is continuous variable. For the categorical variables, the mean distance must be used. Okay, so to how like they will be asking like how to choose the value of k. So k is a value for hyperparameter which need to choose during the time of model building. Also, small number of neighbors are most flexibly fit, which will have the low bias. Okay, but high variance. Large number of neighbors will have smooth decision boundary, which means lower the variance, higher the bias. We should choose an odd number. The name of classes and the number of classes is even. We have to choose the odd number. So if the number of classes is even, it is said that the most common values are to be 3 and 5 actually. So now there will be a questions they will be asking related to the libraries basically. What is a pipeline in sklearn? So pipeline is what a chain the several steps together initial explanation is done. Okay. So for example, some codes are meant to transform the features into the vectors, turn to the text into the vectors, or fill up the missing data, and they are the transformers, right? Other codes may be meant to be predicted the variables fitting an algorithm. Okay, so this is a particular thing, and for a such an random forest or support vector machine, they are estimators. Okay, pipeline chain all this together, which can be applied for the training data in a block. Okay, so example of a pipeline that imputes the data, that includes the data with most frequent value of each column, then fit into the decision tree classifier. Okay, and what you do is from sklearn.pipeline, you're inputting the pipeline library. So you will be telling that this is an imputation particular feature I'm using. I'm imputing this missing value 9. Okay, most frequently the strategy is most frequent and access is number of rows or columns you are applying, that depends upon that, and you are performing this. Okay. Okay, all right, folks. So instead of fitting to one model, it can be looped over several models to the best one. Okay, so classifier, which is equal to k nearest neighbors of 5. Random forest classifier function, gradient boost classifier, or CLF and classify number of classifiers you are going to do it basically for this. So you are importing the pipeline here for the particular steps that you are going to do it. Okay, so this is a particular thing for each and every algorithm you will be computing this cross-path code. Okay, then another questions will comes to your mind is like what is a PCA? The main idea of principal component is to reduce the dimensionality of the data set. Let's suppose consisting of many variables correlated with each other. They are either heavily or lightly. Alright, heavily or lightly. So variables to nest a new set of variables basically. So the same is done by the transforming orthogonal to the new set of variables which are known as principal component or simply the principal component and our orthogonal order set such as the retention of variation presence in the original variable decreases as we down in the order. So in this way, first principal components retains the maximum variation that we present in the original component. The principal components are eigenvectors of a covariance matrix, hence they are orthogonal. Okay. So main point important points you have to consider is like you have to normalize the data to calculate the covariance matrix, you have to calculate eigenvalue and iterate matrix, and you have to choose the components forming from a feature vector. So forming a principal component. So they will be asking like what is a TSNE? So TSNE is nothing but T distributed stochastic neighboring embedding is a non-linear dimensionality reduction algorithm used to explore high dimensional data. It maps a multi-dimensional data to two or more dimensions suitable for human observation. With the help of TSNE algorithms, you may have to plot fewer exploratory data analysis plots next time you have to work with high dimensional data. They may be asked like VIF, like during the logistic regression we will do that, right? So why and when to use? Okay, okay. So VIF is nothing but variation inflation factor. So it provides an index that measure how much variance of an estimated regression coefficient is increased because of collinearity. Okay, like VIF which is equal to 1 by 1 minus r square of jth variable, where r2 of the jth variable is the coefficient, r square is the jth variable of the coefficient of determination of the model, which includes all dependent independent variables with jth predictor. If the VIF is greater than 5, then the problem with it is a problem with code. Then there is a problem with the collinearity, multi-collinearity. Understanding VIF like predicted variable is 5. This means that the variance of the coefficient of predicted is 5 times the larger of the predicted value, uncorrelated with the other predicted variables. Okay, in other words, we can say that VIF of a predicted variable is 5. This means that the standard error of coefficient of predicted variable is 2.23 times. So root 5 which will be equal to 2.23 value, right? So these are the things you have to consider. Weight of evidence and information value are the simple yet powerful techniques to perform the variable transformation and selection. Okay. So here is a simple table that shows how to calculate correct these values. Okay. So uh, right now this is a variable name, mean value, max value, count, event, non-event, event percent, non-event percent, weight of evidence. Okay. So how to evaluate data does not have any outlier. So once how do you evaluate that data does not have like outliers? In statistics, outliers are the data points that don't belong onto the certain population. It's an abnormal observation that lies away from the other values. Okay. Outlier is an observation that diverges that otherwise well-structured data. Okay, so how do you detect that? First, number one, method one is standard deviation. Okay, standard deviation in statistics, if the data distribution is approximate normal, then about 68% of the data value lie with one standard deviation of the mean. Okay, and 95% are within the two standard deviation. About 99% lies with the three standard deviation. Okay, so this is the thing, like 68% will be lying in the normal distributed. And method 2 is you will be finding the box plot. Box plot are graphic notation like through the quantiles. It's very simple but effective way to visualize the outliers basically, right? So think about the lower and upper whiskers as the boundaries of data distribution. Any data points that shows above or below whiskers uh, can be considered as outliers or anomalous. Okay, so you can use a violin plots for that as well. You can use a scatter plots based upon the use case. What you do if there are outliers? If the outliers are there, what you will do? You will drop the outlier records, assign a new value if an outlier seems to due to the mistake in your data. You try to impute a value. Okay, if a percentage wise number of outlier is less, when we see the numbers, there are several several, then in that case, dropping then might cause the losing insight. Okay, we should group them in that case and run our analysis separately on them. Okay, what are encoding techniques you have applied with examples? Okay, so what are the encoding techniques? One is a label encoding, another one is a one hot encoding. Label encoding, we map each category to a number or a label. The labels chosen for the categories have no relationship. So categories that have some ties or are close to each other lose each such information after encoding. One hot encoding, in this method, we map each category to a vector that contains ones and zeros, denoting the presence of feature or not. Okay, so number of vectors depends on the categories which we wanted to keep. For high cardinality features, this method produces a lot of convenience, slow down the learning significantly. So you have to like another question is like trade-off between bias and variances and the relationship between them. Whenever we discuss a model prediction, it's important to understand that prediction errors, bias, and the variance. Okay, the prediction error for any machine learning algorithm can be broken into three parts. One is a bias error, variance error, irreducible error. Okay, so so um, irreducible error that reduces the regardless of what algorithm is used. If it is an error introduced, changing the frame of the problem and cause factors like unknown variables like influence the mapping of input variables of output variables. So bias is a nothing but it is a model favors one results more than the others. Bias is a simplifying assumption that makes by the model to make target function easier to learn. So model with high bias pays very little attention to the training data and oversimplifies the model. Okay, it also leads to the high error. Variance is like amount that estimate of the target function will change if different training data is was used. The model will with high variance pays a lot of attention to training data and does not generalize on data which is it has not seen before. Okay, so you can see the distribution like this basically. Okay, which has high variance, high bias, and low bias, low variance, how it will be. Okay, so overfitting, high variance will be regards to overfitting, high bias will be like to underfitting, good balance will be the low bias and low variance. Okay, so now there will be another question like what is the difference between type 1 and type 2 error and severity of the error. Type 1 error is also referred to as a false positive and it's an incorrect rejection of true null hypothesis in favor of alternative. In the example above, like null hypothesis refers to natural state of things, like stating that patient is HIV is negative. Okay. Alternative hypothesis states that patient is HIV is positive. So many medical tests will have the disease they are testing for the alternative hypothesis or lack of that disease in the null hypothesis. Okay, so they don't have okay false positive. Okay, correct rejection of true. Because they have, but the particular thing is they are telling that true negative. Right, this is the thing. Okay, so type 2 error is like false acceptance of null hypothesis that is not true, false negative, or type 2 error would entail patient if they are free of HIV and when they are not. Okay, so what is a binomial distribution and polynomial distribution? Binomial distribution can be thought of as a simply probability of a success or failure outcome in an experiment or a survey that is repeated multiple times. Coin a toss, only two possible outcomes. And tails, take a test, could have two possibility outcomes. Polymers, like in probability theory, the multinomial generalizing variable distribution models probability of the count of each side of a case added die n times for n independent trials, each of which lead to the success probability. Then multinomial distribution gives the probability of any particular combination of numbers of successes for various categories basically. So there will be a common question like what is a mean, what is a median, what is a mode. Okay. So mean is nothing but average of all populations, like average of all data points will be going to do it. Mode is like frequent items, right? Median is like middle value. Standard deviation is like how much spread out in the statistics, like how the data is spread out. So then, what is a mean absolute error? Absolute error is the amount of error in your measurement. Okay, it is difference between the measured value and a true value, right? And mean absolute error is like a xi minus x bar. Basically, this is the thing. Mean absolute error, basically. What is the difference between long data and wide data? Okay, wide data, the data size, data set that emphasizes in handling the data about a single subject and columns is called as wide data set. Okay, so this is a particular thing, and these are the you can just have a look, folks, and keep a note of it and understand, put it to your thing sets. Okay, what is the data normalization method you have applied and why? Normalization is technique that after applied of a data preparation for machine learning, goal of normalization to change the values of the neighboring columns into the data set to common scale without distorting the difference in the range of the values. Okay, so machine learning, every data set does not require normalization. It is required when the features have the different ranges. Okay, in simple words, if I want to talk about it, so when multiple attributes are there, but attributes have values in different scale, this may lead to poor data models while performing the data mining operations. So they are normalized to bring all the attributes to the same scale using the something between 0 and 1. Okay, it is always a good idea to normalize the data since we might lose the information about the maximum and minimum values. Sometimes it is a good idea to do so. For example, ML algorithms such as linear regression, support vector machine typically converge faster on normalized data. So on algorithms like k-mean, k-nearest, normalization could be good choice. Okay, so this is a particular thing. So min-max normalization, we'll be going to do it. These are the thing. What is the difference between normalization and standardization? This question normally they will ask. In ML, every practitioner knows that feature scaling is an important issue. The two most discussed scaling methods are normalization and standardization. Normalization typically means it rescales the values into the range of 0, 1. Alright. And it rescales the value of range 0, 1, folks. Okay, it is an alternative approach of C-score normalization standardization. It is also called as min-max scaling. Okay, so oftenly called as normalization or to the ambiguities. In this approach, scale to the fixed range, usually 0 to 1. Scikit-Learn provides a transformer called min-max scaler for this. A min-max scaling is typically done by the following equation. X norm is equal to x minus x minimum divided by x max minus x minimum. Okay, so this is a particular thing. After normalization, you do like this, and this. Okay, all right. So this is all about the D3 part, folks. I wanted to continue the things, though everything is now done. So these are the common things they can ask. Okay, have a look into it. Okay, so you will get understanding better. Okay, for standardization, Z-score normalization, some of the things we'll be going to